multiplying and dividing rational expressions and functions. So a rational expression is something that is written in the form of a fraction. It is an expression if there is no equal sign, and it is a function if there is an equal sign. So for example, when we look at any rational expression or function, we need to consider the domain. So here we have 3 over negative 18x plus 9. If we look at the domain refers to the x values that you can use for the x variable. So we're looking at the x values. When we look at the domain, we need to look at restrictions. We know that negative 18x plus 9 cannot equal 0. You cannot have division by 0. So if we solve this down, we subtract 9 from both sides, divide by our negative 18, then we get that x cannot equal 1/2. So that is our limitation on our domain. It means that we can have everything else, but we cannot have x equaling 1/2. Look at another one. If we're told f of x equals x cubed minus 64x all over x squared minus 81. So again, we need to look at the denominator. If we look at the domain, we are looking for x squared minus 81 to not equal 0. Well, x squared minus 81, that's a perfect square. So that would be x minus 9 and x plus 9. So that means that x cannot equal, well, let's do our intermediate step here. It means that x minus 9, we don't want that to be 0. So let's solve it for where it is, and then we'll look at all the other cases. Same thing with x plus 9. So here we get x equals 9. Here we get x equals negative 9. So our restrictions are we do not want x to be 9, and we do not want x to be negative 9, because if we substitute those in, we'll get division by 0 in the denominator. Let's look at one more. If we have h of x equals x minus 3 over x squared plus 81. Well, this is very similar to what we had in the last one with x squared minus 81 in the denominator, but this time it's x squared plus 81. That is not a difference of two squares, and that actually doesn't factor. So in this one, there are no restrictions on our domain. So now that we've looked at domain, let's do a little bit of simplifying when we have a rational expression. So let's say we have x squared minus 5x all over x. So this is an expression because there is no equal sign. So if we want to simplify an expression or a function that we have in a fraction format, the first thing we want to do is see if it will factor. So for this one, we have x squared minus 5x. So in that numerator, I can factor out an x. If I factor out an x from x squared, I'm left with x. If I factor out an x from 5x, I'm left with minus the 5x all over x. You can always check this by distributing it back. X times x is x squared. X times negative 5x is negative 5x. Whoops. Good thing we checked it. When I factor out that x, when I pull out that x, it should just be x minus 5. Let's check it again. X times x is x squared. X times negative 5 is negative 5x. Now we've got it. Now notice, we have a multiplication of an x in the front, and we have an x in the denominator. These are common factors. That means that they will cancel, because x divided by x is just 1. So all that we're left with here after we simplify is x minus 5. Let's look at another one. Let's say that we have m squared minus 25 all over 4m minus 20. So let's try to factor. Let's look at the numerator first. This is the difference of two squares. So that gives us m plus 5 times m minus 5. In the denominator, what's in common between a 4m and a minus 20? Well, if I pull a 4 out of those, I'll be left with m minus 5. m minus 5 is in common between the top and the bottom, so that will cancel. That leaves us with m plus 5 over 4. Let's try again. xy minus yw plus xz minus zw all over xy plus yw plus xz plus zw. And be very careful. You have a lot in common between the numerator and the denominator, but right now everything is broken down as separate terms. You cannot cancel because there's nothing pulled out into the front of the numerator and the denominator. Yes, there's an x plus y term here. Yes, there is an xy term here. Yes, there is an xz term here. Yes, there's an xz term here. But you can't cancel these because they are not pulled out to the front using our multiplication of the terms. So instead, let's factor the numerator, let's factor the denominator, so we can get things that we can pull out, and then we'll be able to factor. And then we'll be able to cancel. So let's do our factor by grouping. On the top, I'm going to group these two and these two. So let's see, what's in common between xy and minus yw? If I pull out a y, we'll be left, so pull out a y, we'll be left with x minus w. Here, what's in common? Well, I know I need x minus w left over, so let's that be our hint. So if I need x minus w, it looks like I need to pull out the z. I'm pulling out a positive z so that I stick with x minus w. So there we go. Let's do the same thing in the denominator. I'll group these two and these two. What is in common between xy plus yw? Well, we have a y in common. So if I pull out that y, I have x plus w left over. I know that I need x plus w, so what can I pull out from xz plus zw to get x plus w? Now we need to see what's in common from the top. I have x minus w, x minus w. So if we pull that out, so I've pulled out this piece, I've pulled out this piece, y plus z is left over. And on the bottom, what's in common? We have that x plus w in common. So if I pull out x plus w, I have left over y plus z. Now we have everything joined by multiplication. We have changed it from all of our terms right here. We have it in factored form. So now we can look and see what is in common between the numerator and the denominator. I see a y plus z and a y plus z. So those can cancel because y plus z over y plus z, that simplifies to just 1. And that gives us x minus w over x plus w as our final simplified result. Let's look at what happens when we are multiplying different expressions together. So let's say we have 32 x squared over y to the 4th times 5x to the 3rd over 8y to the 2nd. A couple ways you can go about this. One option is to look and see if there's anything in common that you can cancel straight away. Another option is to do your multiplication and then try to cancel. So if we look at this and we try to note what's in common, well, you're looking for commonalities top to bottom to try to cancel. All we have is our multiplication. We do not have any addition or subtraction, so we're okay to go ahead and try to cancel. I don't have any x's in the bottom, I don't have any y's in the top, so nothing's going to help me out there. But look at 32 over 8. I can simplify that quite a bit. 8 times 4 is 32, so 32 over 8, if I had that as a fraction, we would reduce that down to 4, or 4 over 1. So I can simplify, there we go. Now we just do our multiplication across the top, our multiplication across the bottom. 4 times 5 is 20. X to the 2nd times x to the 3rd, remember we add our exponents. y to the fourth times y to the second. Remember, we add our exponents. And there we go. Let's try again. P squared plus 7p plus 10 all over p plus 5 times 1 over p plus 2. In the last question, we did not have any addition or subtraction, so we were able to go ahead and start canceling. Here we have some addition, so we cannot go ahead and start canceling. Before we can cancel, the first thing we need to do is try to factor, so we can get this all down to our multiplication. So if we factor, we need two numbers that multiply to 10 and add to 7. So that's going to look like p plus 5 and p plus 2. Now we can do our multiplication. So remember, when you multiply straight across the top and you multiply straight across the bottom. So that's going to give us p plus 5 times p plus 2, and then on the bottom we'll have p plus 5 times p plus 2. We can look to the numerator and to the denominator to see what cancels. So p plus 5 cancels with p plus 5, p plus 2 cancels with p plus 2, so this simplifies to just 1. Let's try again.
Mom, can you use school marks when you